Colorado Dam diversion water tunnel for when they built the dam. The Hoover Dam, of course. They had to build these by hand.
Section of penstock, so you know then that the water flowing below us is going to eventually be shot out into a turbine and spin up one of these generators we are about to go see. So you would imagine then that could be quite a lot of water flowing beneath us, and you would be correct. All four of these penstocks together at full capacity can move through 1 acre-foot of water every second. If you are wondering how much that is, you can imagine an American football field with a foot of water on top of it. You are now imagining quite a lot of water. That's how much we're talking about. Now, let's say one year we got a whole lot of those football fields of water coming down the Colorado, perhaps too many for our penstocks to handle. We have to have a plan for that scenario because we cannot allow that to result in water flowing over the top of the Hoover Dam. It is not designed for that, and if that were to happen, it would spell certain disaster. So to avoid that, we have two spillways, one on the Arizona side, one on the Nevada side. These automatically take on the water that would flow over the top of the dam and rather just send it safely around. Now, fortunately, we have only even ever had to use those spillways to avoid that disastrous scenario just one time in 1983, which is why I have a photo from that year up on the wall. So you can see in the foreground here what it looked like
inside the dam. Looks like a mine almost.
Electric power, beyond than it is serving the needs of so much of the American West, is that anyway, this is what made building the Hoover Dam possible. See, it was agreed that in order for Congress to appropriate the funding necessary for this project, that repayment on the Hoover Dam would have to be guaranteed by the revenue paid here in the power plant. And folks, as of 1987, all of those initial costs have been paid off with this revenue here, but I would imagine you are probably more so curious about what is going on in front of you at the moment, so let's talk about that. We have got 8 of these large commercial generators in this wing, the Nevada wing. Behind me some ways is the Arizona wing. It's got another 9 generators over there. All of these together make enough power for around 1 million homes. You can see just how each one of those generators is contributing to all that power with this rotor in front of us here. Each one of our generators has a rotor a lot like this inside of it. You can make out the top of one of those in context. It's that silver shaft poking out of the middle of our first generator, N1 or Nevada 1. You can tell that generator is referred to by that name, of course, by the label on top. If that label were lit up, you'd know that generator is operational. So it looks like at the moment in this wing, N5 is the only one operational. So in there, the rotor is currently spinning at 3 revolutions per second. And our strongest generator can take that spin and turn that into 178,000 horsepower. Now, truthfully, there is one more generator with the light on right up front here, the N0 generator. It's kind of servicing. We're part of the very first circuit to be completed all the way back in 1937, and that power went to Los Angeles. So you're probably then wondering, what is going on with this 1937 rotor? Well, in order to explain that, let's compare one of these generators to a musical instrument, say a guitar. While they're operational, like I said, you have the rotor inside spinning. That means that rotor would then be vibrating at a certain frequency, like you might pluck a guitar string to get it to vibrate at a certain note. So the way that we know that something is wrong with one of these rotors is if, in a way, they are humming out of tune. And that is exactly what was going on with this rotor right here. The vibration analysis that we did revealed that there was a crack in one of its arms. So we've pulled it out, taken it apart. We have successfully addressed that issue with the crack, and we are now in the process of putting this thing back together. Now, you're probably also wondering how it is we're going to lift this up and get it back down into the 3rd generator down the wing there, which is conspicuously missing a top at the moment. Well, if you look up a little ways from there, you are going to see an American flag. That American flag rests on a bridge crane, and that bridge crane is capable of lifting 300 tons. Here's the thing, that bridge crane is going to have to be combined with the other one you can make out just behind it for a lifting capacity of 600 tons, because this rotor, put all the way back together, is going to weigh around 580 tons. These cranes can be combined together and move across the whole 650 feet of the wing here using that rail you are seeing up on the side. I really mention that length of the wing because it happens to be an excellent reference to understand the massive size of the dam. See, at its thickest, the base of the dam comes in at a quite similar 660 feet long. So you can imagine just about the length of this wing, extending out behind that wall with the benches on it. And you'll now have a pretty good mental image of just how much wall of the dam is between you and Lake Mead from where you are supposed to be coming along for the second half of your dam tour. Those of you with those red, white, and blue wristbands, please have them out and visible. Head on over to Daniel, continue on your dam tour. If you do not have a wristband, if you have no idea who Daniel is, you are standing around here with me for a moment, and I will bring you back up to the visitor center to conclude your tour. Thank you.